In radical equations, your goal is to solve for x, which is typically underneath a radical, and the way you get rid of the radical is you square both sides. However, before you square both sides, you need to isolate the radical first, get it by itself on one side, then you can square both sides, and then solve the equation, and this time you need to make sure to check your solutions, and we'll show you why in a little bit. Here we go with our first problem. Very easy, and we're going to work our way up to some more difficult problems. X is trapped under a radical. The radical is already isolated by itself on the left, so we're just going to square both sides. Squaring the left just lifts off the radical and gives us x plus 2. Squaring the right gives you 25. Now, subtracting 2 on each side, you get x equals 23. And that is very checkable. You take your 23, substitute it back in, add 2 to get 25, which square roots to 5. So yes, that does check. Problem number 2. We have a cube root in this problem, and you undo a cube root by, you guessed it, cubing both sides. So when you cube both sides, you lift off the cube root, and on the left you have x minus 4, and on the right 2 cubed makes 8. Adding 4 to both sides, you get 12, and take your 12, substitute it in, subtract 4 to get 8, cube root it, you get 2. Check, that works also. Now, on number 3, I see something right off the bat. I see a square root equal to a negative. The left side is positive, the right side is negative. And so, right off the bat, I want to say no solution. Now, let's pretend you don't see that, and you go and you square both sides. Squaring both sides lifts off the radical on the left, giving you x plus 5. Squaring the negative 2 gives you 4. Subtracting the 5 on each side, you get negative 1. When you go to check this, substituting the negative 1 back in, adding the 5, you get 4. The square root of 4 cannot equal negative 2. This needs to be no solution for this problem. Now, it's another time for another one of my cheesy analogies. If you think of this radical as a jail and the x plus 5 is trapped underneath, what we're trying to do is we're trying to bust out of jail when we square both sides. Whenever you want to bust out of jail, you want to make sure the coast is clear. And that is the part of isolating the radical, making sure the radical is by itself before we square both sides. But you also want to watch out for the negatives. Those are the informants, okay? And so, there's an informant nearby, and we can't have a square root equal to a negative. That's what we're going to watch out for and have no solution. On problem number 4, we have a square root on both sides. Don't let that scare you at all. We're just going to square both sides, and the left side becomes x squared plus 5x, and the right side lifting off the radical is 150. Since this is now a quadratic equation, we need to set it equal to 0, subtracting that 150 on both sides. And then we can factor what is left, which factors in this case into x plus 15 times x minus 10. So we get two solutions. The first one is negative 15, and the second one is positive 10. And we really have to check these. When we take negative 15 and square it, we get 225. 5 times negative 15 is negative 75. So 225 minus 75 is 150, and the square root of 150 equals the square root of 150. I told you a moment ago to watch out for negatives, but in this case a negative got squared and we had the square root of a positive, so it was okay. Now let's check the 10. 10 squared is 100. 5 times 10 is 50. 100 plus 50 is 150, and so that problem checks also, and we have two solutions for it. Okay, those are the easier problems. Now we move on to kind of a more difficult problem, and again our variable y is trapped under a radical. This radical is isolated on the left by itself, so we can go straight to squaring both sides. Squaring the left lifts off that radical, giving us 9y squared minus 8y plus 1. And on the right, this is where mistakes occur. That does not become 9y squared plus 1. That on the right is a binomial, and when you square it, you have a FOIL problem. So I'm going to leave the left side as it is, just copy it down again to the next line. And on the right, we're going to have 9y squared, the first term of FOIL. We're going to have a plus 3y and a plus 3y, inner and outer, making plus 6y. And the last term of FOIL, 1 times 1 is 1. Now, when we go to solve this, getting all the y squareds to one place, hey, these 9y squareds cancel out. And it turns out the minus 1's will cancel out also. And you're left with negative 8y equals 6y. Now that looks a little bit strange, but it is okay. We're going to get all the variables to one side, so I'm going to subtract off that 6y on each side. That will give us a negative 14y equals 0. And dividing each side by negative 14 will then give us 0 on the right hand side. And 0 is the solution to this problem. Notice when you substitute it in, all the variables disappear. You just get the square root of 1 on the left, which is 1. And on the right, 3 times 0 is 0 plus 1, which is 1 on the right. So we just have a single solution of y equals 0.